to a particular special type of sequence called an arithmetic sequence. A sequence is arithmetic if a sub n plus 1 minus a sub n equals d for all values of n. So in other words, the easier way to think of this is the difference between any two terms is always a constant. And we're going to call that constant d for the common difference. And so this formula, which we just generated, the nth term is going to be the first term plus n minus 1 times that common difference. And so now with this formula, we should be able to tackle any problem that deals with an arithmetic sequence. Alright, so before we dive into some particulars, let's make sure that we can identify what type of sequence is arithmetic. Alright, so which of these are arithmetic? Which means we add a common difference. Okay, so let's look. To get from negative 4 to 3, what did we do? Well, we have to add 7. How about to get from 3 to 10? Oh yeah, we add 7. And 10 to 17? We add 7. So this is an arithmetic sequence, and the common difference is a positive 7. Alright, how about the next one? We're at 1, we get to negative 1. Well, we had to subtract 2. But then we go negative 1 to 1, that's adding 2. And then 1 back down to negative 1, that's subtracting 2. Adding 2, subtracting 2. That's a pattern, definitely, but it's not the pattern we're looking for. We're looking for adding the same number every time or subtracting the same number every time, not alternating. So this one is not an arithmetic sequence. How about the next one? 2 to 4, that's adding 2. 4 to 8, we're adding 4. Well, already we know this is a problem. 8 to 16, adding 8. 16 to 32, adding 6. So this is definitely not an arithmetic. We're not adding the same amount each time. But there is another pattern here if we don't think of addition. How about we think multiplication? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. There's a multiplication pattern going on here. We're multiplying by the same number each time. That's actually another special type of sequence that we're going to be interested in, and we'll study that next. That's called a geometric sequence. But for now, that's not arithmetic, so we move on. Alright, so how about this one? 11 to 6, we subtracted 5. 6 to 1, we subtracted 5. 1 to negative 4, minus 5. Negative 4 to negative 9, minus 5. This is an arithmetic sequence. This time your common difference is a negative value, it's negative 5. Now, make sure that you're checking all of these. Don't just do the first two and say, you know, oh, minus 5, yeah, it's good, it's arithmetic because it's the same. You have to make sure that you check all of them. If the last one, for example, was negative 8 here, then that would be minus 4, and then it would not be arithmetic. So you do have to check all of them before you decide if it's arithmetic or not. And then how about the last one? That's one of my favorites. This confuses students sometimes because you say, well, no, we're not adding anything. It's just 1 all the way across. Well, let's be more technical. We're actually adding 0. So we are adding the same thing every time. So this is an arithmetic sequence. Your common difference is just 0. All right, let's jump to some examples. Find the first term, that's a sub 1, and the common difference, that's d, of the arithmetic sequence in which the second term, that would be a sub 2, is equal to negative 2, and the 8th term, a sub 8, is equal to 40. So we know the second term and the 8th term. How do we get the first term and the common difference? Well, if you're a formula person, which I don't advise just always diving into formulas without having understanding, but the formula we learned was that the nth term is the first term plus n minus 1 times d, the common difference. And yes, we actually could use this to work this problem out. Let's start with, we have a sub 2. So a sub 2 is going to equal a sub 1 plus n minus 1, so 2 minus 1 times d. And then we can plug in some values. So we know what a sub 2 is. a sub 2 was negative 2 equals a sub 1, which we don't know, plus 2 minus 1 is 1, times d, which we also don't know. Alright, now let's use the a sub 8. A sub 8 is equal to a sub 1, using the formula, plus 8 minus 1 times the common difference. So now if I plug in the values I know a sub 8 is 40, a sub 1 I don't know, 8 minus 1 is 7, and then the common difference I don't know. So what do we have here? I have two equations with two variables. Well, that's a system of equations. And I guess I could solve that. Use elimination, because the a sub 1's are going to cancel. So negative 2 minus 40 is negative 42. A sub 1 minus a sub 1 is 0. And then 1d minus 7d is negative 6d. So when I divide by negative 6, I get d is equal to 7. And then I can figure out the first term by plugging that into one of my two equations. I'd probably use the first one because it's simpler. And if I plug in 7 for d, then I know a sub 1, how can I write this? A sub 1 is going to be negative 2 minus 7, which is negative 9. And then I've got my two answers that they asked for, so we're done. Okay, and that's great, it works. Some people like to do that. Let me put all this over to the side for a second. Shrink that down, there. Alright, and that works for you. But I want you to consider another method, and this is the way I like to do this. So, we're dealing with 8 terms, so I'm just going to put a blank. A sub 1, a sub 2, a sub 3, a sub 4, a sub 5, a sub 6, 7, and 8. So this is the first term, this would be the second term, here's the 8th term. And I have values. I know the 8th term is 40, and I know the second term is negative 2. Just from there, I can figure out what the common difference is, because to get from a sub 2 to a sub 8, I'm adding the common difference once, twice, 3 times, 4 times, 5 times, 6 times. So if I take negative 2 and I add the common difference 6 times, I should get to 40. Notice, that's the same equation I had when I solved my system the other way. I'm going to add 2 to both sides, I get 42, divide by 6, I get your common difference is 7. And then to get a sub 1, well, instead of adding 7 to move to the right, I'll subtract 7 from a sub 2, negative 2 minus 7, and that gives me a sub 1. So, different ways to find the answer. Either way is fine, but I think it's important that you understand conceptually what's going on. Don't just try and memorize formulas. Alright, let's try another example. Write a formula for the nth term of this sequence. Alright, we want the nth term. We have the first term, a sub 1, and to get to the next term, what do? We add 3, add 3, add 3. So the pattern is add 3. So that's our common difference. So I know a sub 1 is 14. I know my common difference is positive 3. So the nth term, a sub n, well, I'm just going to take my first term, which is 14, plus n minus 1 times the common difference, which is 3. I guess I could clean this up a little bit. I could distribute and combine like terms. So I'm going to wind up with 3n, and then minus 3 plus 14 is plus 11. And so now I have a formula for the nth term for this particular sequence. Okay, find the 20th term of the arithmetic sequence if the second term is 9 and the 8th term is 51. So once again, you can set it up. I like, since they're not that far apart, I'm just going to use some blanks. So a sub 1, 2, 3, 4, 5, 6, 7, 8. This is a sub 8. This is a sub 2. And they gave us those values. A sub 2 is 9. And the 8th term was 51. It's an arithmetic sequence. We want to find a sub 20 which is way over here. So how can I find that? Well, first of all, let's find the common difference. To get from the second term to the eighth term, we have to add the difference once, twice, 3 times, 4 times, 5 times, 6 times. You could just do 8 minus 2 to figure that out. So if I have 9 and I add the common difference 6 times, I should get 51. So we get 6d equals 42. So d is equal to 7. So our common difference is 7. So therefore, I know the first term is going to be 9 minus 7, because I'm going backwards, and so that's going to be a 2. So a sub 1 is 2. So to get the 20th term, a sub 20, that's going to be the first term plus 20 minus 1 times the common difference. So my first term is 2. 19 times my common difference, which is 7. So the 20th term is going to be 7 times 19. So that's 70 and 63, 123, plus 2 is 125. Did I do that right? 70, 63, no, it's 133, sorry, 133 plus 2, so 135. 135. Always double check your work. Okay, looks good. Let's try another one. Could you also have done this with a system of equations like we did before? Yes.